Yeah, good evening, everyone. Welcome you to this evening section. Today we'll be looking at some concepts that are very, very, very important in health statistics. Okay, so we'll be looking at ratio, and we'll be making some calculations. Okay, so we look at ratio, we'll be looking at proportion. We're going to be looking at proportions as well. Then we're also going to look at width. Okay, so these are the things we'll be looking at today. Okay, so we'll begin. First is a ratio. And a ratio is the relative magnitude of two quantities or a comparison of two values. It is calculated by dividing one interval or ratio scale variable by the other. The numerator and the denominator needs not to be related. Therefore, one could compare apples with oranges or apples with number of physician visit. So what we're trying to talk about here, in ratio, it compares two quantities who unnecessarily they shouldn't or must not be of the same origin. Looking at the example they gave us here, orange and apples, you can compare. You can make that comparison using ratio. The ratio of orange to mango is this. Could either be the ratio of orange is 1:2. The ratio of orange to mango is 1:2. Okay, so that means if for every one orange, there is two apples. Okay, so that is what ratio is all about. And ratios are very, very important in epidemiology and as health workers, as community health workers, as public health workers, we make use of ratio to make some important analysis. It can be used as an analytical tool. It can also be used as a descriptive tool. So when we get there, you will understand what we mean by analytical tool or a descriptive tool. Methods for calculating a ratio. Number or rate of event, item, persons, or etc. in one group. Now, after the numerator is divided by the denominator, that is the process of calculating. Let's say we have 10 oranges and we have 20 apples and we want to find out the ratio. Okay, so we're going to divide one by the other. One must be equal to one. What do I mean? When you divide them, one must end in one. You will see. Say, after the numerator is divided by the denominator is the down number, while the numerator is the upper number. The result is often expressed as the result to 1 or written as the result 1. I don't know if you understand. Take, for example, between 2020 and 2022, as part of the National Health and Nutrition Examination Survey, 7,381 persons aged 40 to 77 years were enrolled in a follow-up study. At the time of enrollment, each study participant was classified as having or not having diabetes. The results are summarized as follows. Okay. Now, of the men enrolled in the study, 3,151 were non-diabetic, and 189, were diabetics. Calculate the ratio of non-diabetic to diabetic. These are two groups of persons. people who have diabetes and people who do not have diabetes. So which means that ratio is used to compare two things, two phenomena. Okay. So now look at after the follow-up study, after the study, this is what we got. After this total 7,381 persons enrolled, the total number of men who came down with diabetes is 189. Why? The total number of men who do not come down with diabetes are 3,152, whereas women who have diabetes were 218. Why? Women who do not have diabetes were 3,823. So this was after a study. Okay, after a study. Now, you are requested to calculate the ratio of non-diabetic to diabetic men, sorry. Now, to calculate the ratio of non-diabetic, so non-diabetic men is 3,152, and diabetic men were 189. So for you to get the ratio, you are going to divide the denominator, which is 189. You divide this 3,152. Okay, so by that calculation, you arrive at 16.7 is to 1. You see what we are explaining earlier. At one of the results, that possibly the denominator will be equal to 1. By the time you begin to divide 3,152 by 189, 189 must end in 1. So what you will do is you just point your calculator, 3,152 divide by 189. So that is how you do it. So now, if you divide it accordingly, like 3,152 divided by 189. You'll find out by the time you divide this thing, 189 divided by 189 is 1. Then you divide 189. Divide 189. You divide 189 by, divide 3,152 by 189. It will be giving you around 16.7. Okay, so now you see what we're explaining then, that 1 will end in 1. So that was what the statement was actually trying to explain. Okay, so that is how you find ratio. So the next we'll look at is okay, let's look at properties of okay, let's take another example of ratio. It says a city of 4 million persons has 500 clinics. Calculate the ratio of clinic per person. So in calculating, since it's a ratio of clinic per person, so what will come forward is clinic. Clinic will be the numerator. Like here, ratio, I call it ratio of non-diabetic men. This is the non-diabetic men. That's why it was the numerator. Here now, 500 clinics comes first, and it's the numerator. So calculate the ratio of clinics per person. So person will be the denominator. So it would be 500 clinics divide by 4 million persons. So by the time you divide, it would be giving you something like 0.00125 clinic per person. So in epidemiology, you can't really explain this because of the decimal places. So for us to actually make it easier, we would have to bring it more than in a comprehensive way, okay? So for us to achieve that, what we'll do is to go by converting, to find a way to convert this to a standard form, okay? So, and for us to do that, we have to use 10,000, okay? We're going to use 10,000. We're going to use 10,000 to achieve that. Okay, so what do? We multiply, because we want to remove this zero here. We want to remove this zero here. If you calculate it, zero, and this is 1, 2, 3, 4, 5. So that's why we're using 10,000. So then the ratio becomes 0.00125 times 10,000, which will now give us 1.25 clinics per 10%. You see, by introduction of this 10,000, we're trying to make it in a way it will be comprehensive. Like in this 4 million persons, by our first calculation, we got that 0.000125 persons. Are you getting me? Per person. Like it is not really realistic. When you try to look at it, you will not really understand what they mean by 0.00125 clinics per person. It's not realistic. It could either be one clinic for 10 persons or 12, one clinic for 15 persons, one clinic for 30%. So that is what we will understand. But by this fraction, we cannot really understand. That's why we introduced this to cancel out those decimal places. So we have to round it up to 10,000. So by that, we would either say per 10,000 persons, like 1.25 clinic per 10,000 person, which still is not really, really understandable. How can you say the clinic can only be one, cannot have a clinic and half by that 1 point. Don't have a clinic and half. So therefore, we will still have to go further to make it in a way it is what understandable. So we now have to divide this. We will now have to divide this each value, that is 1.25, and express this as ratio, as one clinic for every 8,000 person. Okay, so that is how you do it. So like we're explaining, for us to make this in a way that is understandable, because this 1.25 is not really understandable. Okay, you can only have one clinic. Okay, for 10,000 people, 20,000 people, we will now have to divide 10,000. Remember, we're in ratio. We are still going to go forward to keep dividing. Okay, we're still going to go forward to keep what? Dividing. Recall, before I process for, recall that this was what was given, 4 million per person has 500 clinic. Calculate ratio of clinic per person, which will now arrive at 500 divided by 4 million, okay, times 10,000. Okay, that is how we're able to arrive to this, okay, because this would give us this fraction. This thing is something that's difficult to explain. So for us to get it in a better form, we will now have to multiply out by 10,000 to cancel out these decimal places, which gave us 1.25. Yet 1.5 is not really explanatory. So we now have to divide 10,000 by 1 1.25 and 1.25 by 1.25. If you do so, we will have 1.25 divided by 1.25, 1, then 10,000 divided by 1.25, 8,000. So at this point, it is now understandable that in this city, one clinic serves 8,000 persons. Okay. Now let's look at properties and uses of ratio. Ratios are common descriptive measures used in all fields. In statistics, ratios are used as both descriptive measures and as analytic tools. As a descriptive measure, ratios can describe the male to female ratio of participants in a study, like we explained. You can use it to describe that in this study, like in the example above, in this study now we can say that diabetic men that came well with diabetes is 189, and non-diabetic is 3,152. So for us to describe the ratio, we will not say that 16.7 or approximately 17 non-diabetic men participated. We are describing 17 non-diabetic men participated, and what we mean is like 17 non-diabetic men participated in the study per one diabetic man. It's trying to give us that to describe that to every one diabetic man, there is 17 non-diabetic man. That's what we're trying to explain here. To every one diabetic man, there is 17 non-diabetic men who participated in the study. That's what we mean by it is used as descriptive measures. Okay. So as a descriptive measure, ratio can describe the male to female ratio of participants in a study. Then as an analytical tool, ratio can be calculated for occurrence of illness, injuries, or deaths between two groups. So here, and I say tools, there are statistical tools used, such as risk ratio or relative risk, odd ratio. So these are used in cohort studies, case studies, okay, to determine the risk a person has. What we're trying to analyze now, the risk a person has for the development of a particular disease condition. Take, for example, the descriptive measure, and like use of ratio as a descriptive measure. Suppose we are conducting a study on the gender distribution of participants in a research project. We want to describe the male to female ratio in our sample. To do this, we calculate the ratio of the number of males to the number of females in the study. For instance, if we have 100 male participants and 200 female participants, the male to female ratio would be 100 is to 200. See how it's not describing it. For every 100 male, there is 200 women. So for us to simplify it further, we divide 200 divided by 100. So 100 divided itself is 1. 100 divided 200 is 2. So it now gives us 1.2. So therefore, the ratio of male to female who participated in the study is 1:2. Now, this ratio tells us that for every male participant, there are 2 female participants in the study. So therefore, descriptive ratio like this help us understand the composition or distribution of a particular characteristics within a population or a sample. As an analytical tool, ratios can also be used as an analytical tool to compare the occurrence of certain events or outcome between different groups. Let's consider an example where we want to compare the risk of developing, let's say, breast cancer between two groups, Group A and Group B. In Group A, out of 500 individuals, 50 developed illness, the breast cancer. Why in Group B, out of 800 participants, 60 developed the breast cancer? To analyze the risk difference, we can calculate the risk ratio, also known as relative risk. The relative risk ratio is obtained by dividing the risk of the event occurring in one group by the risk in other group. In this case, the risk ratio would be 50 people who developed that breast cancer over the total population who participated in the study, and 60 persons, that is why this one is for group A, and 60 persons who developed breast cancer over the total number of persons who participated in the study in group B. So therefore, by the time you divide this with this, it will give you, when you divide 500 divided by 50, or 50 divided by 500, it will give you 0.1. And 60 divided by 800 will give you 0.07. So at this point now, we arrive, the risk ratio is 1:33. Risk ratio now is 1:33. This means that individuals in group B, this group B, have a 1.33 times higher risk of developing the illness compared to those who are in group A. You see? Okay. So now, what ratio does? You can use ratio to do analytical or analysis. From this now, we can say, people in group B, they have 1.33 times higher risk of developing breast cancer to people in group A. You see, so now we have analyzed. Unlike in the other one, when we did descriptive, we are only using it to describe. So ratios can be used to describe and can also be used for analytic purposes. So now let's move down to proportion. A proportion is the composition of a part to the whole. What this means actually, let's say there is 100 persons in 2 year 3. Out of that 100%, 20 came down with malaria. So that is a proportion of the whole. Okay, so that's what proportion is all about. So bear it in mind that the numerator, that is, the numerator is part of the what? The denominator. In which the numerator is including the denominator. You might use a proportion to describe what fraction of clinic patients tested positive for HIV, or what percentage of the population is younger than 25 years of age. So a proportion may be expressed as a decimal, a fraction, or percentage. So now in this health statistics we will be studying in other topics, we will find out at some point some statistical tools or indicators used for calculation. Some end in percentage. Those ones are proportion, because the actual numerator is part of the denominator. Method of calculating proportion: number of persons or events with a particular characteristics or disease over total number of persons or events of which the numerator is a part or a subset of the proportion. Okay, so and multiply by what? 100. Okay, it's usually multiply the n, it's usually 100. Example: calculate the proportion of men in this study follow-up who were diabetics. In that one we did. So we want to calculate the proportion, no longer the risk, no longer the ratio or the risk. Now we want to calculate the proportion. Now, the numerator of men who were diabetics, the total number of men who were diabetics were 189, if you can recall. Number of men who were diabetic were 189. And then the denominator, which is total of those who were diabetic plus those who were non-diabetic. People who were non-diabetic, men who were non-diabetic, 3,152, and men who were diabetic, 189. So when you add the two, it will give you 3,340, okay, as total men who participated in the study. So therefore, 189 divided by total men who participated, who participated in the study times 100 will give us 5.6%, and which is the proportion of diabetic men who participated in the what? In the study. So that is proportion. So in proportion, the numerator is part of the denominator. Uses of proportion. Proportions are common descriptive measures used in our field. In epidemiology, proportions are used most often as descriptive measure. For example, the proportion of men who were diabetic. So we have described it that 189, I'm sorry, we have described that 5.66% or 6% of men were diabetic. We're just describing that's 5.66% of men were diabetic. 5.6% of men who participated in the studies were what? Diabetic. Or the proportion of children in the village vaccinated against measles is 5%, okay, or 10%. All right. Now, rates. In health statistics, a rate is a measure of the frequency with which an event occurs in a defined population over a specified period of time. Disease, because rates put disease frequency in the perspective of the size of the population, rates are particularly useful for comparing disease frequency in different locations at different times. So what does it mean? That it will tell you that infant mortality rate in Nigeria is higher compared to what is obtainable in the US. So rates are used for comparisons at different locations or among different age groups. And rate is also a measure of risk, because if we say that these people, they have higher rate of this, it tells us how fast that disease or how bad that disease condition is in that area. Okay, so one of the measures of rates is crude birth rate. Okay, crude birth rate is one of the indicators used. Crude birth rate is total number of live births in a year times mid-year population. Okay, so that's what crude birth rate is all about. So we're going to look at this in the next couple of lessons. Thank you, and God bless you.